Hello and welcome. In this video we are looking at some higher tier content for GCSE physics, and it's all based around this formula here. And the formula says energy transferred is potential difference times charge. Now, because it's on the higher tier, it's more than just a question of being able to use the formula, so you actually need to understand what this means. Now the key, I think, to understanding this is being very carefully aware of this idea of potential difference. Potential difference actually means the amount of energy per coulomb of charge. Now if you have a potential difference of 10, that means that every coulomb of charge has 10 joules of energy. Okay, so that energy there is measured in joules. So 10 volts means 10 joules of energy per coulomb of charge. Now, if we then multiply by the amount of charge that we have, that can give us the total amount of energy transferred into a light bulb or into an appliance or into a component in a circuit. Just to give you a quick example, here we have a little circuit and the potential difference across this resistor is 6 volts. That means there are 6 joules of energy for every coulomb of charge passing across this fixed resistor. And in the question here, or in this little diagram here, the charge flow is 5 coulombs. So if we know there's 6 joules per coulomb and there's 5 coulombs, the energy transferred for this data here is basically 30 joules of energy. Okay, so the key to understanding this really is this idea here that potential difference means amount of energy per coulomb of charge. Now let's see how that looks in a potential question. Here I've got a circuit, it's a series circuit, 12 volts across the power supply here. We've got two bulbs, bulb 1 and bulb 2, and if you measure the potential difference across bulb 1, it's 8 volts, and potential difference across bulb 2 is 4 volts. Now the first part of the question here says how much energy is in each coulomb of charge leaving the battery. Well, if we remember that potential difference means amount of energy per coulomb of charge, that's fairly straightforward. The potential difference is 12, so it's 12 joules per coulomb of charge. Now that's just talking about the battery here, but if we're looking at bulb 1, so for question 2, how much energy is, let's put the answer in there. So for question number 2, it says how much energy is transferred by 10 coulombs of charge by bulb 1. Now be careful here, because it'd be very easy to use this 12 volts here to do our calculation, but if we're measuring the potential difference across bulb 1, it's actually 8 volts. So that means 8 volts per coulomb, and we've got 10 coulombs of charge, so that would be 8 times 10 equals 80 joules of energy. 80 joules of energy are transferred by bulb number 1, and for bulb number 2, similarly, make sure you're using the potential difference across the bulb and not in the circuit, and that will be then a simple case of it's 4 joules of energy per coulomb, and there are 10 coulombs, so it's 4 times 10 equals 40 joules. Okay, so we have 40 joules of energy being transferred for 10 coulombs by bulb 2, and 80 joules of energy being transferred for 10 coulombs by bulb 1, and in total we have 120 joules of energy for 10 coulombs. That's mentioned in the question. And if you think about it, if we work it back down to 1 coulomb, we've got 12 volts, that's 12 joules per coulomb, and that means 8 joules per coulomb would be for bulb 1 and 4 joules per coulomb for bulb 2. So it all kind of adds up and makes sense. Okay, so that's how you use the formula. That is energy transferred equals potential difference times charge. The key is probably remembering that potential difference means amount of energy per coulomb of charge, and that should help you when you come across a question that is revolved around this formula. Thanks for watching, and I'll see you again soon.